Okay, this lesson is about the second part of Section 6.1, Law of Signs. And in this section, we're going to talk about what they call the ambiguous case of the law of signs. Okay, so what that means, first of all, let's talk about our different types of triangles that we could have. All right, if I have a triangle, okay, here's my triangle, here's my height. This is side um, B, okay. If my side A, okay, here's my side A. All right, here's my height. If side A is shorter than the height of my triangle, then there's not going to be a triangle that exists. Side A cannot be less than the height of my triangle. So in this case, when A is less than the height, I have 0 triangles because it's not possible. Okay, if I have another triangle, okay, here's my triangle, here's my height. Okay, here's side B, here's angle A. So this would also be side A. So when side A equals my height, I have one possible triangle involved. Okay, so let's look at my third situation here. What if I had this? Okay, this is angle A, so this is side A. Here's my height. Okay, if A is greater than or equal to side B, okay, here's side B. So if A is greater than or equal to side B, I still have just one triangle. All right, but look what happens if I have this. Okay, I'm going to draw my triangles in. It's not a very pretty triangle, but here's my height, H. Okay, here's angle A, here's angle B, here's angle C. And this right here, we're going to call this side, this angle right here, B1. Okay, this is side A, this is side B, here's my other A. If A is in between, if A is greater than H but less than B, so here's side A, if A is greater than my height but less than my B side, I have two possible triangles. Okay, um, here, right here, that's one triangle. This right here. Here's my other triangle right here. So the ambiguous case of the law of signs, sometimes you're going to have to follow steps to figure out which scenario do I have? Do I have 0 triangles? Do I have 1 triangle? Or do I have 2 possible triangles? So on your notes, I listed the steps that you're going to follow in order to figure that out. Okay, the reason we didn't do this the first section in part 1, because I didn't want you to have to worry about how many triangles you had. I just wanted you to learn how to use the law of signs. Okay, so from now on, when we solve triangles using the law of signs, then we will always figure out how many triangles do I have, and we'll do that by following these steps. Okay, so step 1 says solve for the missing angle. So in example 1, okay, I'm supposed to solve triangle ABC. I have angle B, I have side B, and I have side A. So what would be my missing angle? Well, my missing angle has to be angle A. Okay, because I have side A, but no angle A. So let's solve for that missing angle. Okay, and we're going to do that by using the law of signs. So here's what I'm using. A over sine A equals B over sine B. Okay, and I'm just going to plug those numbers in. So 25.1 over sine A equals 8.94 over the sine of 55 degrees, 40 minutes. Okay, from this point, we're going to cross multiply. 25.1 times the sine of 55 degrees 40 minutes equals 8.94 times the sine of angle A. Now we're solving for angle A, so I need to divide by 8.94 on both sides. and I get sine of angle A equals this whole thing. All right, so here's the deal. I can put this in my calculator. I'm looking for an angle. So when you want an angle, you're going to hit second sine. So there's two ways you can do it. And I'll just go ahead and bring my calculator up. Let me bring it over here. Okay, first of all, you need to make sure you're in degrees. Guess I need to turn it on. So I need to be in degrees. Now I'm going to go ahead and put this in my calculator. So since I'm solving for an angle A, I know that we have to hit second sine to find the actual angle. Now I'm going to be entering a fraction, so I'm going to go ahead and hit my fraction button. Okay, so I have 25.1 times the sine of 55 degrees, so second angle, 40 minutes. And I'm going to close parenthesis, and then divided by 8.94. Okay, and I'll go out here and finish my bracket. Equals. Uh-oh. Okay, so there's a reason why I got that. All right, it says error. Okay, if I were to just put this part of my equation in, let me see if I can get that back up. Okay, I'm going to go through here and I'm going to keep everything, but I'm not going to find the second sine of it. I'm going to delete that part. I just want this fraction. Well, maybe I want that fraction. 2.31. Okay, that's what sine of angle A equals. 2.31. Well, the reason we got an error message, not because we made a mistake, because sine can't equal anything over 1. Okay, so this is not possible. Sine of angle A will never equal 2.31. So when you do the problems on this assignment, if you get an error message, check your work, but chances are you didn't make a mistake, that that triangle does not exist. That goes back to this case, okay? A must have been less than H, and I don't have a triangle. Okay, so example 1, no triangle. Okay, let's look at example 2. Example 2, I'm still going to follow those same steps. All right, so solve for the missing angle. So let's look at what we have. We have angle A, we have side A, we have side B. So I need to find angle B. And I'm going to do that by using the law of sines. So I have A over sine A equals B over sine B. So 22.8 over the sine of 55.3 equals 24.9 over the sine of angle B. Now we're going to cross multiply. I'm going to put it over here. 22.8 times the sine of angle B equals 24.9 times the sine of 55.3. I'm solving for sine B, so I'm going to divide by 22.8. Okay, so since I want to know what angle B is, I'm going to put this in my calculator, but when I put it in my calculator, I'm going to hit second sine, and that will tell me what my angle is. So, second sine, I'm going to go to my fraction button, 24.9 times the sine of 55.3 over 22.8. Now I'm going to press enter. All right, so my angle is And we're going to round to the nearest tenth, 63.9 degrees. Okay, so we did step one. We solved for the missing angle. Then it says, find the supplement of your angle you just found. This is my other possible angle to see if I have two triangles or not. Okay, so I know I have at least one triangle because this worked. All right, so remember supplements add up to 180. So my supplement, let me do this in a different color. 180 minus 63.9. Well, 180 minus, oops, 180 minus 63.9, 116.1. Okay, so let's look at the, oh, okay, so we found the supplement. Take the supplement and add to the original angle given in the problem. So my original angle was 55.3. Okay, so I'm going to add 55.3 to that. That's 4, 11, 7, 1. Okay, if my answer is greater than 180, then I only have one triangle. If it's less than 180, then I have two triangles. Okay, so I have two possible triangles. All right, my two possible triangles, here's one, angle B is 63.9, and my other angle B, because I'm going to have two of them, is this 116.1. Okay, so let's call this B1, and then my angle B2 is 116.1. Okay, what we got when we found the supplement of this angle. So once we have our two angles, we have two separate problems to solve. Okay, so I'm just going to kind of divide this up. Okay, I know angle A, I'm going to write that down for this one. Angle A was 55.3. I found angle B at 63.9. So let's find angle C, 180 minus 63.9. I'm adding these two angles together and subtracting from 180 to get my third angle, 60.8. So angle C is 60.8 degrees. That's in this triangle. Let's go over here and find the angles for my other triangle. That angle A will stay the same for both triangles, but we're going to have a different angle C. So 180 minus 116.1 plus 55.3. So angle C in this triangle is 8.6. So I found all the angles. Now I need to find side C for each. Okay, so let's find side C for this triangle. Okay, well that means I have to use, let's use A over sine A equals C over sine C. So that means A is 22.8 over sine of 55.3 equals C over sine 60.8. So I'm going to take this cross multiply. 22.8 times the sine of 60.8 equals C times the sine of 55.3. To solve for C, I'm going to divide by the sine of 55.3. So C equals 22.8 times the sine of 60.8 over sine of 55.3. So C equals whatever I get when I plug that in. So let's plug it in. 22.8 times the sine of 60.8 equals divided by the sine of 55.3. So this side C is 24.2. Okay, now we have to find side C for my other triangle. Again, I'm using A over sine A equals C over sine C. And I'm going to get a different answer because my angle C's were different. Okay, so A in this problem is still 22.8. So 22.8 over sine of 55.3 equals C over the sine of 8.6. Cross multiply. 22.8 times the sine of 8.6 equals C times the sine of 55.3. Solve for C by dividing by the sine of 55.3. So side C equals, move this over, 22.8 times the sine of 8.6 equals, divided by the sine of 55.3, 4.1. Okay, my sides were measured in feet, and I have my three angles. They gave me two sides, and I have my missing side, my three angles, and my missing side. Okay. The last example I want you to try on your own. This right here should be a degree mark. Okay, and you only have one triangle, so that should help you. So do example 3, following these steps, and then solve by using the law of sines.